In our last class, we have already solved a few numericals based on polynomials. In today's class also, we will be solving a few more problem sums based on polynomials, which are of level 3. So let's get started. The first problem sum is about if the HCF, highest common factor, of the given polynomials we have, as we can see, we have two polynomials. So these two are given polynomials, and the HCF of these two polynomials is this. It's given. Now we have to find the maximum value of p plus q minus r. Now what we will do is, as we can see in these two given polynomials, we have three factors: x plus a, x minus b, and x plus c, and along with them we have some constant coefficient, and every factor has some power or exponent value. And in the HCF also we have the same three factors, and it also has its own power or exponents. So first, in the tabular form, we will be writing all these different factors for every polynomial and also for HCF, and then we will calculate that what could be the maximum value of p, q, and r, and from there p plus q minus r. Now this is the form that I was talking about. In the first column, I have written all these three factors: x plus a, x minus b, x plus c, for first polynomial, for second polynomial, as well as for the HCF. In the first polynomial, the power or exponent value of this factor x plus a is p, as it is given. Similarly, for the second factor x minus b, it is q and q minus 3. For third factor x plus c, it is r and r plus 2. And for HCF, all the power or exponent values are same, that is 6, 6, and 6. Now between p and p plus 3, for those two polynomials, p and p plus 3, the minimum value of p could be 1. So for the first polynomial, the power could be 1, and for the second polynomial, it could be 4 for the first factor. Then if we take the value of p as 2, then for the second polynomial of the first factor x plus a, the power value could be 5. Now if we choose the value of p as 3, then for the first polynomial, the power of the first factor will be 3, and for the second polynomial, the power value will be 3 plus 3, it will be 6. That means now for the first value, when p is equal to 1, for the first polynomial, the factor will be x plus a, and for the second polynomial, the power of the first factor will be what? It is p plus 3. So if it is 1, then it will be 1 plus 3, 4. And what is the common factor here? It is x plus a, and the power value is, that means 1. That means in HCF, for the first factor x plus a, the power value will be 1. But here it is not 1, as it is given, it is 6. So if we want this value to be 6, this value means the power for the first polynomial, it has to be 6, and then power for the second polynomial, it is p plus 3, so it will be 6 plus 3, 9. And that means the maximum value of p could be, in case of first polynomial, 6, and for the second polynomial, 6 plus 3, it is 9. But why it is maximum value? Because after 6, if we choose any other value, like if we even choose 7, then it will be 7, and 7 plus 3, it will be 10. Then between these two polynomials, for the first factor, the common factor value will be how much? Then it will be x plus a, and the common value is 7. So it is 7. So it is exceeding the given value 6. So that means we can go till 6. That is the maximum value that we can choose for p. And the same logic is applicable for q and r as well. For q, what is given? For the first polynomial, it is q, and for the second polynomial, it is q minus 3. And in case of HCF, the power value for this factor x minus b, it is given 6. So if you want this power value for the second factor 6, then the common value of that power for that second factor between these two polynomials has to be 6. So if we choose the value of q as 9, then only, since it is q minus 3, so it will be 9 minus 3, 6. In that case, the common value will be 6 for that particular power. And if we go for the third factor, then again in the HCF, the power value is given as 6. Now if we look at the polynomials, then for the first polynomial, it is r, and for the second polynomial, it is r plus 2, it is given. So now if we want this value to be 6 in case of ACF, then the value of R has to be chosen as this value. If we choose as 6, then this value will be 6 plus 2, 8, and the common value will be 6. Otherwise, suppose if we choose the value of R as 5, then it will be 5 in the first polynomial, and for the second polynomial it will be 5 plus 2, it is 7. So the common value of that power for the third factor will be 5. Now if we choose suppose the value of R as say 8, then it will be 8 for first polynomial, and it will be 8 plus 2, 10 for the second polynomial. And what is the common value then? For that factor it will be 8. So that is also not matching because the value is given already in the AC, and that is 6. So it has to be 6 and it will be 8. So that way the values of P, Q and R that we have calculated so far, that is P is equal to 6, Q is equal to 9 and R is equal to 6. So it will be 6 plus 9 minus 6. So 6 will cancel and then the final value will be 9. That is the maximum value of P plus Q minus R based on the conditions which are given in that problem statement. Now let's go to the second problem sum. We need to evaluate these expressions can be called as algebraic expressions, and this is also polynomial where we have two parts. So what we will do is we will simplify this. Now in the first term, what we can see in the numerator is we have x plus y whole cube, then x minus y whole cube. So it is in that format, aq plus bq. So we can use that identity, and then we will simplify step by step, and then we will reach to the simplified answer. aq plus bq, we are already familiar with that identity. So aq plus b cube is a plus b whole cube minus 3ab multiplied by a plus b. Now if we go by that identity, so it will be a plus b, means x plus y is a plus b, x minus y, then minus 3ab, this is a, this is b, and again multiplied by a plus b. So a is x plus y, b is x minus y, and divided by 2, and minus the second term y multiplied by 3x square plus y square, and then we will simplify. So here plus y minus y will cancel each other in both the terms here. Then what will remain is 2x, x plus x, so 2x whole cube minus 3. Here again it resembles one another identity is a plus b multiplied by a minus b, so a square minus b square, that is equal to, so accordingly it is x square minus y square, and from here it is 2x, and then we have this second term. Now 2x whole cube means 8x cube minus 3, then multiplied by 2x, so it will be 6x, and we have this factor x square minus y square divided by 2, and then again we have this second term in that given expression, and now we will simplify the whole thing. And what is this? This is actually the formula, the identity x minus y whole cube. So this is the simplified answer of the given expression. Now the next one, we need to find the square root of this given algebraic expression, which is not actually a polynomial. So we need to find the square root, and we know the rule of finding square root of a polynomial. So this is the solution, where this is the given algebraic expression we have written here. And what is the variable here? The variable part is a, and what is the highest power of that variable? It is 2. Then we have a term where we have 1, the power of a, and then we have this constant term. So constant term means it is a to the power 0. A to the power 0 is 1, that we know. And then we have this term where we have minus 1 by a, that means a to the power minus 1, and we have plus 1 by a square, means a to the power minus 2. So sequentially if we arrange, then a square, this term will come first, then this term, then the constant term, then this term, and then the second term. So as per the rule of finding square root of a given polynomial, we need to choose a term such a way here that if we take the square value of that term, then it will always try to vanish the term which has the highest power of that variable. So that value will be less than or equal to that term which has the highest power, but that will never exceed. So here if we choose a by 2, this term, then a by 2, and if we take the square value, means if we multiply by another a by 2, so it will be a square by 4. So a by 2 here we have written, and on the other side this is again we have written a by 2. This actually is going to be the square root value of the given algebraic expression. So when we will multiply these two values, we will be getting a square by 4. And now what will happen, we will subtract, means we will simplify, so there will be change of sign, so these two terms will cancel each other. Now the remaining terms we will be writing, so it is 1 by a square, or we could have done this way, that the sequence that I have just told you. So a by 2 first, then the constant term, then this, then this. But I have written as it was given, no issue. So 1 by a square minus 1 by a, then plus a by 2 minus 3 by 4. Now what we do, the value that we have obtained here so far, we will be taking the double value of that. So we will be doubling that value. So a by 2, when we will multiply by 2, it will become a. And that value we will be writing here. Then the rule of finding square root by using long division method. Now we will be adding such a term, and when we will be multiplying by the same term, then it will try to vanish the variable which has the highest power. Now at least again it will not exceed that value, so it will be less than and equal to. So the variable here is a, so and here the value of the variable which has the highest power is a by 2. So if we multiply a by half, then we know it will give you a by 2. That means we are multiplying a by half. So we will be adding half with a, and then we will be multiplying by the same term half. So it will be a by 2, and then the second term will be 1 by 4, and that's what has been done here. So a plus half, and then we have multiplied again by half. So a by 2 plus 1 by 4, and this half that we have added and multiplied by, that term we have written here. So the first term, then the second term. And now again what we'll do, the change of sign, now we will be simplifying. So a by 2, and here it is minus a by 2, so that will cancel each other. Minus 3 by 4 minus 1 by 4, so it will be minus 1, means minus 4 by 4, so it will be minus 1. And then the other terms, so 1 by a square minus 1 by a. Now in this expression, among these three terms, this constant value, constant term minus 1 has the highest power of that variable, because all other variables have been written in the denominator. So the power of a here is minus 1, and power of a here is minus 2, a to the power minus 2. And since it is constant term, so minus 1, as I said, that minus 1 can be written as minus 1 multiplied by a to the power 0. Now what we will do, so far we have these two terms in the result. So a by 2 plus 1 by 2, so we will be doubling that value, so we will multiply by 2, so it will be a plus 1, and that value we have written here, a plus 1. Now again we will be adding such a term, and when we will be multiplying by the same term, the whole thing, then it will try to vanish the variable which has the highest power. Here the highest power of the variable is 1, so this is the term a, and here the highest power of the variable is 0, so that term is minus 1. So how to get minus 1 from a? When a will be multiplied by minus 1 by a, then this a will cancel each other, and the result will be minus 1. That means the term that we will be adding here is minus 1 by a. Now initially we had these two terms, a plus 1, and now we have added this term minus 1 by a, and we will be multiplying by the same term minus 1 by a. So what will be the result of multiplication? A, and when it will be multiplied by minus 1 by a, it will be minus 1. Then 1, when it will be multiplied by minus 1 by a, minus 1 by a, and minus 1 by a, when it will be multiplied by another minus 1 by a, it will give you 1 by a square. So this is the result of multiplication that we will be writing here. So we have rearranged the terms, and now the change of sign. So minus 1, here it will be plus 1, they will cancel each other. Minus 1 by a plus 1 by a will cancel each other. Then minus 1 by a square, and it is plus 1 by a square, so they will cancel each other. And finally there will be nothing left, so remainder will be 0. And the term that we have added and we have multiplied by, that we will be writing here, that is minus 1 by a. And this value, a by 2 plus half, then minus 1 by a, this will be actually the square root value of the given algebraic expression. Now the next problem, where we have again an algebraic expression, it has three terms, as you can see here, and we need to find the square root. So here we will not be applying the method that we have just applied in the previous case. So what we will do in this case is we will simply use the relevant identities. Now what we can see here is in the first part it has a square value minus, again in the second part it has a square value. So it's like a square minus b square. So it will be a plus b multiplied by a minus b, that identity. So this is the solution and this is the identity I was talking about. So a square minus b square, a plus b multiplied by a minus b, and that has been used here. So the whole thing 4a plus 5b plus 5c, that has been taken as a or x, whatever, and the second, in the second term 5a plus 4b plus 4c, that has been taken as b or y. So you can think this way, x plus y multiplied by x minus y. So a, all these three terms, plus b, again all these three terms, they have been added, and then again a minus b. So it is a plus b, and here it is a minus b, and then the third term as it was given in the statement. Now we will simplify further. So from here, what we can see here is 9 is the common factor. So we have taken 9 common, and then a plus b plus c, or b plus c plus a, and from the second factor it is b plus c minus a, and then the third term. So here again it is in that the same identity in that format. So b plus c plus a and b plus c minus a. So b plus c again can be taken as x. So x and a can be taken as y. So x plus y, x minus y. It's like that. So b plus x square minus y square. So b plus c whole square minus y square means a square, and then plus 9a square, the third term. So now if we simplify further, then 9 b plus c whole square. Then from here if we multiply 9 with minus a square, so minus 9a square, and then here we have another plus 9a square. They will cancel each other, and what will remain finally is 9 b plus c whole square. And what we needed to find was square root of that given algebraic expression. So this is the basically the simplified form of the given algebraic expression. So from here we need to find the square root value, and it's simple. So square root value will be 3 and then b plus c. Now the next one and the last one of this class, find the square root of this expression. So again we will not be applying the method, the long division method. So what we will do is we will simply take the LCM and we will simplify. So here we have x, y, z in the denominator. Here we have x, y and z. So if we take the LCM, it will be x, y, z. So in the first part it will be x square plus y square plus z square, as it was in the first term. And in case of second term, it will be, here we have x in the denominator. So xyz divided by x means yz. So 2 will be multiplied by yz. For the first part it will be 2yz. Here we have y, so it will be 2xz. Here we have z, so it will be 2xy. And then x square plus y square plus z square plus 2xy plus 2yz plus 2xz, that actually resembles the identity x plus y plus z and then whole square of that. So directly we have written that, and then divided by x, y, z. Now we need to find the square root value. So square root, when we will find, in the numerator it will be x plus y plus z only, and in the denominator it will be root over x, y, z. Now if we simplify further, this is the answer, this is square root value. Now we can simplify further. So if we do that, then here we have x, and in the denominator we will split all the terms, we will separate all these three terms. So in the first term it will be x divided by root over x, y, z, then y divided by root over x, y, z, and so on. So here in the numerator, in the first term, in the numerator we have x, and in the denominator we have root x. After simplification it will be in the numerator root over x, and in the denominator root over yz will remain, and accordingly in other terms also. So this is the most simplified form of the square root value of the given algebraic expression. So this was about polynomials. I hope this class was meaningful for you. With that, hope I end today's class. Stay safe and stay healthy. Thank you.